Okay, so let's review the previous lecture, and I'm going to extend the previous example to standard coding style. Okay, so we could define classes, maybe circle, circle, maybe the center x, center y, and we can define a drawing function, right? So maybe you can define a draw circle function like this one, maybe, or in this style you can draw circle const this is not C style. In C style you can x, y, right? This is a C style implementation of draw circle. In C++, you can define a class which includes data, the member variables, center x, center y, and maybe you can add radius like this. And you can define behavior or action. So this draw circle draws this circle, right? Using these data, right? So we all know this one, and we can also do this one. So in C style we can draw a circle like this, or center 100, 100, maybe 10, right? So we can do this in C style, and OP style is a little bit different. So we define an instance of this circle. So my circle, define an instance of class circle. And my circle, draw circle. We can do this. But at this time, we don't have these information. We need this. We need them. So there is one way. My circle, so center x, center y, okay, and well, these are a little bit dirty, so maybe we can define an initialize member function, or simply let's do init. So const integer input x, const integer y, const integer and okay, so we can define an initialize function. So we can replace these by one line. So this looks better than this one. Okay, and there is one more thing we can do. We can define a constructor like this. Okay, so in constructor, well, there are several ways. So you can use this init function one more time. So you can do this, right? You can do this, or, well, I recommended this one because this reuses init function. Okay, but there is one more way. You can do the same thing in this way. This is interesting, right? So this member variable is initialized by the value of this variable, the input variable, when this instance is initialized. Okay, so it's interesting and useful. So you can do this. YR. Okay. So, well, I usually recommend this one, but this is also very useful. Okay. And sometimes, well, if you try to compile this code, you will find an error. Not well. This is not an important one. Yeah, this one. Well, many of you usually complain this error. So no appropriate default constructor available, right? So if you do not any constructor function, if you do not any of constructor function, the compiler defines this one by default for free. Even if it doesn't appear, there is a default constructor function. But if you define at least one of the member function, the constructor, then compiler does not generate this one. So you have to manually define this default constructor. You should, well, you need to define default constructor when you defined at least one of constructor like this one. But well, in some cases, well, you don't need to define default constructor if you do not use default constructor. Okay, so we have a constructor and we can use that one like this. Okay, looks good. And OP and pointer. So, and we can also define the instance of this circle, like this one maybe. So we can initialize this pointer by using null pointer. But this is usually 1. So old style. In old style, yeah, these are old style, and in modern C++ we use null ptr, constant. Okay, and we can initialize circle like this one. Right? And well, actually we usually do like this. If my pointer is not null pointer, well, this is more safe. This is safer than, well, blind new initialization. This is safer. And after using my circle ptr, well, you need to delete memory before this program ends, right? So you can do this like this. Well, you can free memory in this way, or you can free this memory only if this pointer was allocated to some memory. Okay. So I strongly recommend this. And maybe we can draw circle like this, right? But well, so but we know that this pointer has an instance because of this one, so we can use this one like this. Okay, so this is the basic class programming, and we can also define class box maybe. Okay, so maybe it has center or left corner, bottom left X. Well, we can define. There are many ways to define boxes, right? So maybe we can define center and edge lengths, or well, there are many ways to define boxes. And we can also define draw box function like this. And well, and sometimes well, you want to use only one for loop. Well, you can draw, just a moment, you can define a box, my box tr, maybe we can use only one line and do something box. Okay, and my box tr, and you can do same thing for okay. And we may like to add many more object types and object types, and so we need polymorphism, right? So let's define a model class. So like this, geometric object maybe. So box has bottom left X and bottom left Y, but let's erase this one. We don't need this one anymore. Okay. Let's make it here. Okay. So circle has center X, Y, and radius. So the member variables are different. Circle is defined by center and radius, but box is defined by these variables. So they are different. But in common, they have draw function. And well, we want to make them have something common. So maybe we can abstract this operation. Okay. So we can define an abstract operation like draw. Right. Draw object. So maybe you can do this. If this is circle, draw circle. If this is box, this is a box, well, draw box. But this requires more work for programmers. So what we like to do is define, well, override the function defined in mother class, so that they can use the same function name. So geometric object. So we can inherit mother class geometric object like this. Public geometric object. Right? And okay, and let's test polymorphism from now. Geometric object. And geometric, what was it? Circle. And box. Okay, let's erase everything. Okay, so we need to use pointers. Let's define a circle. My circle. And box, my box. Okay, we don't have constructor yet here, and we can test my circle, draw, my box, draw. Okay, so this one draws circle, this one draws box, right? And we may cast the object pointer and the box pointer to geometric object. Okay, so let's compile and execute. So they work as they are geometric object, but if you use virtual function in mother class, geometry object class, it behaved as they were, circle and box. Okay, so this is an implementation of polymorphism. Okay, and more interesting things are using just a moment. So let me use a vector, standard vector instead of array. So you can define an array of pointers of geometry object of geo, right? You can do something this one. I taught you this one previously. Or you can use standard library like this. So geo vector, and you can do interesting things. Push back, new circle. Oh. Push back. Okay. And you can use a for loop for okay, I'll show you an old style first. So, well, there are several ways. Okay, so integer I is from 0, I, go vector, dot size. Go vector, this one, the standard vector is a kind of array, but it has more functions inside, so we can use it conveniently. I plus plus, go vector, I, draw. We have draw. Okay. So it's working. The polymorphism is working, and we can use one for loop. And let me explain more about the standard library. Okay, so there are more traditional way is defining an iterator instead of integer I. So iterator like this, and where is it? Yeah, go vector dot end, and I think okay. Well, I don't like this style, but it's too lengthy, right? It's not good. But anyway, let's confirm it how it operates. So go. So we have iterator here instead of integer I, right? So star itr arrow draw. Okay, so it's working. Up. What's wrong? Abort. Oh, okay, itr was not initialized. So go vector dot begin. Okay. So you can do this. Circle and box. It's working. And if you think that this one is too lengthy, maybe you can use auto. This is one way. So this is very convenient. You don't need to type all of these. So just use auto. It's working. And I think there are better way. Modern C++ vector iteration. Maybe. So a proper way, a faster way. There are so many articles, but so let's choose a random one. So not this one. Yep. So, do you see it? So, I showed you a very old style. It's too lengthy, and yeah, this is an old style, and I showed you a shorter one, and I believe this one's gonna work. Okay, so for auto and go vector. Is it going to work? No. We don't need this one. So it's working. Okay, so this one looks much better. I haven't used standard library because of this coding style. I really didn't like it. But well, recently I found this is very useful with this one. Well, it's very convenient. You don't need to implement all of the arrays and well the standard data structures. You can simply use this one, and well, very readable, right? So it's a good coding style, I think. Maybe you can do this. Looks much better, right? Okay, so I reviewed polymorphism, and I also explained a little bit about standard library. And well, if you are doing homework or some light work, not that much mathematical application, if you are writing not that much, well, complicated operations, then I strongly recommend using standard library. It makes you more productive. But sometimes if you have to optimize some part of your mathematically complicated algorithm, then, well, you may need to write your own data structure. But, well, it's a far story, I believe. Okay, so I explained a little bit about this stuff. Okay, so I coded everything in the source.cpp file to explain the polymorphism, but this is not we do. This is not what we do in general. Okay, so let's erase everything and not everything. We are just okay. So let's remove everything except for the main function. Okay, so let's begin from this point. Okay, so we want some geometric object, and circle and box classes works in this way. Okay, so in general, you define one class per one .h file and one cpp file in general. Okay, let me show you. So there are many ways. So maybe you can use a wizard, class wizard. There is a wizard here. Okay, so you can simply type a class name you want here. So you may use it in easier way, and you can see base class here. Okay, but well, I don't use this wizard stuff in general. So if you want to use wizard, then well, you can use it in an easy way, but I will show you how to do it manually. Okay, so right click and add new item here, header file, and in general, well, you use the header file with the class name. So we are going to define 3 classes: geometry object, box, and circle. So it means that we are going to generate 3 files: geometric object, right? Okay, let's do this. Okay, and this pragma once means that, well, the compiler takes care of this file only once, even if this file was included twice or in many places. So you need this one. In old style, you can define maybe h object. This is an older style. I don't recommend this one. And if not, define this if ndef class and if, well, you can do this, but instead of writing all of this, you can simply use pragma once. This one's much better, right? Yeah. Okay, and virtual void draw. Okay. And okay, let's go to source.cpp. But we defined geometry object class here. We defined it, but compiler said, well, compiler still complains about geometry object is undefined. So we need to include it. Include, this is, well, we defined geometry objects.h, right? We made it. So it's not a standard library. So we need to double quote here, and it appears geometry object here. Okay, so it disappeared. So the compiler knows where geometric object class is. It's in this file, right? Okay, good. And we also need to define circle and box classes, right? So let's do it. Maybe add new item, and we want to define circle. Okay, so class circle. It's complaining about cout and end line, so we need to include this one, geometric circle here. So it's okay now, right? Okay, and it seems like we need circle.h file here as well, right? So let's do this. Include circle.h file. So it's okay now, right? Well, let's remove constructor because, well, I don't want to code everything here. And well, we remember that circle included IO stream, right? And this source.cpp included circle.h. So we don't need this one here. It doesn't make any compiler error. So this circle.h included IOStream, and we included circle.h here. So it automatically includes IOStream. So we don't need this one here, because circle.h also include this one. So, but this doesn't make any trouble. You can duplicate include operator because we have pragma once here. So in your homework level project, this doesn't harm any of your performance. But if your project is very big, this kind of duplicated including slows down your compiler greatly. So maybe you can use precompiled header later, but I don't want to handle the precompiled header for this class. But and let's define box.h as well. New item box.h. Okay. So class box public and this also requires include IOStream. Okay. Yep. What's wrong? Okay. Well, the compiler says that you cannot cast circle class to geometry object class because we didn't do inheritance. So let's go to circle and public geometric object. But it's not gonna be compiled because this file doesn't have a geometric definition of geometric object. So we include geometric object here. And it also means that we need to include it in box.h like this. So public geometric object. what's wrong? Box. Okay. We need include box.h here. Okay, so everything's fine. Okay, it's working, right? And there is one more thing you need to know. In this case, the body of this function was defined in header file. Okay? It means that if you touch something related to this header file, all of the other parts should be compiled one more time. So we separate declaration and definition, the header and body, maybe declaration or body. Well, I'll show you. Okay, so let's add new item. So CPP file. In this case, I was taking care of box class, box, right? So we want to move the body of this class to CPP file. Okay, this is a function definition, right? This is a function definition. So we want to define this draw function as a member of box class. But the box class is not defined here. It's warning, so we need to include this one. Okay. Box.h. And it's also complaining the standard cout. Oh, okay. So IOStream was included in this header file, right? And this header file included IOStream. So it has no problem. But sometimes I recommend moving this one to CPP file. But this doesn't harm the performance of your program or your compiler, well, in general. Okay. So this is okay, and in this case, you can right-click this CPP file and compile this CPP file only. And it's complaining about what's wrong? Oh, I moved the IOStream to the CPP file, so it doesn't know about this one. So let's move this one, and let's see this one. This drawbox draw already has a body, right? So this one, this is the body, right? So it has body in H file and it has a body in CPP file. So we need to remove one of them. So I like to remove this one, so that the header file include declaration only. So this is declaration, DECLARA declaration, and this is definition, the body. Okay. So this is what happened here. So you can right-click it, and you can see go to definition or go to declaration. So if you click definition, it's going to your compiler or IDE, your Visual Studio IDE will try to find this declaration. If you click this and go to definition, it's going to try to find this definition or body. Okay. Okay, and this main function uses draw function of class circle and box, but this one is executed through geometric object class, right? You got it? Yeah. So in Java programming, well, we call this one interface. Well, especially Java programmers love this wording. because, well, it's something between this application layer, application level, and circle and box and some other children implementation. So it's between something. So we call it interface. So if you are more interested in this keyword, you may Google interface, CPP, well, OP maybe. Yeah, interfaces.